Now I would like to introduce the VLF-90KV Hipot test set produced by UHV. It is suitable for electrical equipment with stand voltage test projects with large insulation equivalent capacitance. When conducting power frequency withstand voltage tests on large and medium-sized generators, motors, power cables and other test products, because their insulation layers present large capacitance, a large capacity test transformer or resonant transformer is required. Such equipment is very bulky and expensive. The 0.1 Hz ultra-low frequency test is used instead of the power frequency withstand voltage test. Not only can the same equivalence be achieved, but the volume and weight of the equipment are greatly reduced. Theoretically, it can reach 1/500 of the power frequency. The operation is very simple and convenient. This is a 90 kV VLF Hipot test set. There are 4 frequency options. The conventional ones are 0.1 Hz, 0.05 Hz, and 0.02 Hz. This one has a 0.01 Hz, and the load capacity is stronger. Now I am using this VLF-90KV Hipot test set to test the load of 6 high-voltage capacitors in series. When doing the test on site, directly clamp the red clip on the test object, and the wiring method is the same. Before the test, the instrument is first grounded. This is the output line, connected to the booster. The line from the host is connected to this end of the booster. It is a multi-socket line. Note that the booster must be reliably grounded. Output from the output end to the test object. Note that the output end should be kept suspended. Maintain an absolute height to the ground. This is a high-voltage booster. This line has been kept suspended, set it up, and keep it suspended and straightened. Because it must be kept at a safe distance from the ground. It is also a safe height. Then come over and connect it to this side, directly connect it to the test object. Clamp it at one end of the capacitor. The capacitor is connected. The last end is grounded. This side is the capacitor, all connected in series. The end of the string is grounded. When on site, for example, when testing the cable, one end is clamped on a core of the cable. Cut off both sides of the cable. Keep an absolute safe distance. This output is clamped on the core of the cable. Its other end is the cable armor. It is grounded. Do not remove the wires. After connecting to the 220 volts power supply, turn the knob. The instrument enters the power on state. This interface can adjust the voltage. You can drag this line to select the voltage. Its highest voltage is 90 kV. Now adjust it like this. Because it is a demonstration experiment, select 36 kV. Select the frequency here. The lower the frequency, the stronger the load capacity. This is the time. The time can be selected and added up and down. This is the overcurrent protection. Return. This is the main interface. Click here to set the interface. After setting, click the return key. After returning, you can see the test voltage, current voltage, frequency, protection current, time. After setting up, click Start directly. The instrument is automatically increasing the voltage. The test voltage has reached 36 kV. The timing has started here, and the timing time is set to 1 minute. After 1 minute, it will automatically reduce the voltage and shut down. When 1 minute is up, it shuts down. This is the setting. The clock. Here can also view the data. This is start and stop. After the whole experiment is done, you can click print. Print out the data. Very convenient. The test is completed. Press the knob directly. The instrument shuts down. Unplug the power supply and discharge. Be careful not to touch the high voltage wires during the test. Stay away from the high voltage wires. Discharge after the test and power off. Remove the wires after the discharge is complete.